So, okay, so this is where we're gonna go. Get ready. Okay, so let's go ahead, guys, and start with this. This chapter, guys, talk about special purpose. We call them the special purpose outlets, and in particular, they're talking about cooking equipments. For cooking equipment, Jeff, my friend, we're going to handle the range. If you have a cooktop and an oven in one standalone system, they call it range. Everybody knows what the range is, right? For the most part, you have a cooktop and an oven in one big standalone. They call it, the code called, this is a range. Then you have the cooktop, which is just a cooktop mounted cooking mounted units, and we have the wall mounted oven. So the way I understand it, either you're going to have an oven here, and if you have a cooktop, where am I here? Cooktop here. This will be your range, or you can have these two pieces separate, right? You have a cooktop and an oven. So just FYI, when we start talking about ranges and cooktops and so forth, either you have an oven with a cooktop all in one, that will be your range, or you have the cooktop or the cooking mounted unit, counter mounted cooking unit, they call it, in one area, and the oven in a different area. Cool? So let's just go a quick review a few things about these. I want to remind you, for dwelling, these are non-continuous loads. So when we size things, we don't size them based on continuous load, as you're going to see in a second here. So freestanding range, that's what they call the freestanding range. We're going to understand the NEC requirement for it. And then the counter-mounted cooking units, that's the cooking units cooktop, wall-mounted oven, so that these two together, if you put them together, they make the oven, the range. And we have the microwave and light energy ovens. Anybody has light energy oven? Looks like microwave. Another technology. Think of it as another microwave type of oven. So these are what we're going to be talking about. I'm going to summarize these two for you. 20 amp circuit, done. 20 amp circuit, done for these two. Right? Everybody's okay with that? Microwave and light energy ovens, typically 20 amp circuit, done. So let's go to the ranges, my friends. So a couple of things I want to go in a second here about the calculation for range. There's a few rules I would like to review with you guys. Calculation for range. I want to tell you a few things about when you have a range or a cooktop or anything. There's very simple things for it. Just to draw that one. Number one, you need an overcurrent protection device, overcurrent protection device. Number two, you need some type of a disconnect, right? And here's my oven, and you need a conductor, right? We're designers and engineers, so the people come to us because of sizing. So when you have an oven or a group of ovens, what do? We don't buy ovens, we don't buy ranges. They come to us so we can size the overcurrent protection device, we can size the conductor and a disconnect. The disconnect for these guys be as simple as a plug, the plug itself, typically the disconnect, or you can have a on-the-wall NEMA rated disconnect like this board. Typically what we use with these is the plug act as a disconnect. Can I have thumbs up, Chad? Know what we want to, what the whole spiel is. Why do we care about ranges? Because we need to size the overcurrent protection device, the conductor, and the disconnect. The disconnect, typically the plug, so we don't have to worry too much about it. Cool? Okay, so that's what we're going to talk about. Here's where disconnect NEMA, thanks God, came up with all these configuration of circuit breakers. We talked about some of them. You guys are going to be looking at some of them in a second here. Control, how temperature control. I don't emphasize too much about the temperature control for cooking units because Andrew, nobody's going to hire you to go design a temperature control for the cooking units in our industry. We are building, so. What people hire us in our industry is to size this, right? We don't do the control, though you can, but we throw these one just a control that's part of the equipment, FYI only. Terminal identification for foreign-made equipment. There's a couple of things, guys. Again, these are FYI only. Terminal identification for foreign-made appliances. I'll mention a few things for you guys. I grew up with the so-called foreign wiring identification. One major thing you have to know, anybody knows what the color in Europe of the grounded conductor? That's, you bring a plug from Europe right now into the US. The grounded, the neutral. What's a neutral? Blue. So would that confuse you or what? If that's even more confusing, it used to be black. So they used to have it black. They switched 10 years ago, and the same thing. Growing up in Jerusalem, we did the same thing. Black was the neutral. Black was the neutral. Brown was the hot. So black was the neutral. Then they switched it 10 years ago into blue. So if you have a plug, an older plug, the black coming with it is going to be the grounded conductor. And the blue, right now, the system, the blue is the neutral. And green is still the ground. Thanks God, the green and yellow. Okay, so these are a couple of things, guys, about the system. These are appliances, so they're covered under appliances, guys, Article 422. When we have a freestanding range or a cooktop, typically what the way they do it, guys, you're going to see in a second here, they have a flexible web that comes to it, and almost always you end up with a cord unplug connection. Anybody knows why they have a flexible web to tie to them, or they tie them with a plug, cord unplug? Ease of movement, ease of maintenance, and the plug is typically for what? For maintaining the equipment. These are appliances. Appliances need a disconnect. So if they're maintaining your electrical range, you need to be able to unplug it, completely disconnect it from the circuit so you can work on it for safety. So that's going to be your disconnect, basically, the cord unplug. So you're going to have utilize direct connection or cord unplug. If you have direct connection, you have to have some type of a disconnect there for the equipment. This is where I would like you guys to highlight it. If the code says if your range is 8 3/4 or more, if you have a range of your range 8 3/4 or more, no matter what your calculation come up with, if your range is 8 3/4 or more, you have to have a 40 amp branch circuit for this range. That's in the journeyman exam always, they stick it. No matter what your calculation come up with, you have to stick a 40 amp circuit breaker and a 40 amp branch circuit for this range. Cool? Minimum, of course, minimum. So the branch circuit must be at least, that's minimum, for any range 8 3/4. The one that you guys have with us it was 8. So when you do a calculation, typically you end up with 40 anyway, 8 kW. But if it's 8 3/4 or larger, no matter what your calculation come up with, you're going to end up with 40. So here's what typically you do. You put your 40 amp here, and your range is, here's my range sitting here. And of course, I have a plug here where I can plug this is just plugging my range. And you put my number, number 8, and we do 8 4 12 2 12 8 4. So you put 8 4 cable into it. It's either hot, neutral, 2 hots, neutral, and a ground. Typically, that's how we wire it. 40 amps minimum for range, standalone ranges minimum. 40 amps, number 8, 4 conductors, 2 hots, and a neutral and a ground, plus a plug here, and you plug that boy here. That's what you guys did for me, right? That's what you did with the plug, special plug that you did. When you guys specify the circuit, when we do takeoff on this project, we're going to be doing takeoff in this project in the spring, and you're going to take off the plug. It's going to be a 40 amp plug, 40 amp plug. You're going to take off a cable that's 8 4, and you're going to take off a 40 amp 2-pole circuit breaker. Everybody's good with that one? Minimum for a freestanding range. A couple of things. Here's how they do some of them. Now, this is a freestanding range. If you have an oven and a cooktop, so Darren, my friend, if you put the oven at the top of the cooktop and mold them together in big box, that becomes the range, right? What's the range? For the most part, one oven or more, and a cooktop at the top, or counter-mounted cooking unit, what they call it. If you have these two, you can mount them together and become a range. Now, a few things, guys, about sizing these. When we size them, this is really nice because it talks about sizing them. When we size them, we have a table when we size them, and we size them based on the feeders, based on the table that we have. and we size them based on table 220.55. And you for branch circuits, you can actually, for branch circuits, you have to use the actual nameplate for branch circuits. And for feeders, you can derate. For branch circuits, you can use the actual nameplate of the equipment when you design a branch circuit. For feeders, you can derate. So we'll do this example, guys, in a second here, but you can see how number 8 is coming here to feed this. And then we have number 10, we're tabbing, there's box to tab these, and we have number 6 feeding the whole system. We have a number 6 conductor, I'm tabbing it with number 10, I'm tabbing also with number 8 to feed these two, and I'm breaking it at 50 amps with number 6, 50 amp with number 6. We'll get into that one when we get into the sizing, guys, in a second here. When it comes to the range, guys, you almost always you're going to be in these ranges. Typically for dwelling, you're sitting at 40 amps. For range, these are called plugs that you use, rated 40 amp plugs and cords that you can use for ranges. 30 amps, typically we talked about 30 amp plugs, guys, and receptacle goes with dryer. So just be aware when you talk dwelling, 30 amp plug and receptacle, you're talking basically dryer, right? When you take 50 or 40 amp plug, you're talking what? Ranges. Just FYI. NEMA configuration. What NEMA, guys, does with this configuration is, let's go back to the configuration. Here's NEMA configuration. When we go, guys, to industrial project, we have a really nice picture list of all the NEMA receptacle and plug configuration. Let's just look at this one. If you guys remember, we looked at something similar. Here's how NEMA 1030, this R stands for what? Receptacle. And the 30 stand for what? 30 amps. And 10 is the number, the NEMA number that they assign for this receptacle. So the plug that goes with this will be 10-30. Anybody instead of the R, remember what we said? P, thank you. So that's the plug that goes with it. Same thing here. We have 30R, 1430R. So that's the only difference between this one. This is a 3-pole. So you're going to have hot 1, hot 2, neutral. Where's your ground here? You don't want these. These are old. They used to have them like this before 96. They're not acceptable anymore. This is a no. You can't use these anymore as a no. These two are not. You can't use them as a no. No installation. So what's your no installation? No installation here. This is your ground. This is your hot 2. This is your hot 1. And what do you think this boy here? Neutral. That's the new installation they use. One more time. 30 is for what? For the amps. R is for the receptacle, and 14 is the number that NEMA give it to this particular receptacle. So here's your 30. If you go to the 50 amp, same thing, guys. Here's 14, NEMA 14-50R, ground, hot 1, hot 2, and neutral. Ground, hot 1, hot 2, and neutral. Any comments, guys? Any questions? Any comments, any questions about the NEMA configuration? So the only thing, this is the one that you're going to be dealing with for range. This one typically for dryers. You don't have to memorize this one. Darren, I used to think, where would I use it as an engineer? So some of you might think, where the heck would I use it as an engineer? Until one time, we were dealing with portable generators for small towns and utilities. Small towns, guys, utilities, what they do is they have portable generator for not some pump, they're lift stations. They have lift station that take the sludge or the sewer system from certain lower area, and they pump it into the wastewater treatment plants. Now, what happens if you lose power in these lift station? Lift station is a well, basically. We bring all this stuff into it, and they pump it to a higher elevation. What happens if you lose power there? Your street will be flooded with sewer. Do you want this to happen in any city? So what the cities do, guys, small cities and big cities, they have a portable generator on a truck, a trailer generator. And what they do now, these are trailer generators. as a backup. So if you lose the transmission line, distribution line in one area, they pull that generator in this area. This generator, the one that we designed, has one of them has 4 plugs in it because they have shouldn't happen this way, but if they don't coordinate, they have different voltages. They run them at different voltages. They have 4 plugs for different voltages. So you have to have a 50 amp or 100 amp plug 480 277. That's when you get into specifying. So as an engineer, we were specifying these plugs right next to the lift station. So you get into NEMA. I need to find an NEMA. Hubble makes all these plugs, the big plugs. You need to get into the NEMA configuration for 100 amp 480 277 for this particular system, so you can plug into the control panel for this lift station and work it. So that's where that's the higher level instead of just a receptacle. That's when these make a lot of sense. Does that make sense? So we get into specifying them because you might say, where am I going to see this? You're not going to see it in dwelling, but you will see it definitely in an industrial application. The way they list them, guys, you have the X, Y, and the W, the grounded, and G. So you're going to have your X here, your Y, these are the hots, this is W, and this is a G. That's how they list them. X, Y is the hots, W is the white conductor or the grounded conductor, and G is the ground, right? When you look at these receptacles. Okay, so that's basically it in terms of configuration. Why do we care about configuration? Because the last thing you want to do is plug a 480 appliances in a 208 system, right? Can you guys imagine the nightmare that could happen if we don't have all these NEMA configuration that could happen? You have a 240 system and you plug in 120, you burn the equipment. And so, for safety, okay, if you have built-in mounted ovens, we have flexible metal conduit tied to it. Typically, they run into a junction box where the electrical connection is made. In most cases, cooktop, the same thing, flexible conduits attached to it, and the conduit is run to the junction box. I'm going to come to this table, guys, in a second here, and explain that table and do some calculation for it. Freestanding electrical range, if we have ranges or cooktop, we always apply the derating factor for feeders based on this calculation. I'm going to go to it in a second here. So that's what I want to mention here. Well, I'm going to go to this table in list in a second here. Okay. So that's it for basically the ranges. I'm going to go do calculation, as I said, in list in a second here, so if you can hold your horses. Load center, and I want to leave this one, guys. We have the term load center and we have the term panel. Anybody knows what the difference between a load center and a panel? Load center and a panel. They look alike. You can buy them single phase 208, 120 load centers and 3-phase 120, 240. The panels are bigger. They have more gutter space where you can pull the conductors. So when you hear the word load center, you are doing residential. Residential, they tend to be smaller. They can fit in the cavity of 16 inches. Stud cavity, smaller in size, made cheaper. So that's basically it. Smaller, make cheaper for typically residential or very light commercial application. For the same size, 100 amp panel. So if you have a 100 amp panel, and they typically tend to be single phase, though you can have a 3-phase. For panels, they tend to be 3-phase. The panel board, they tend to be bigger in size, and they tend to be for commercial and industrial, of course, application. And later on, you're going to see, guys, when we have a presentation when we go into the commercial project about color hammer. We have an expert in panel boards, and we come and we walk you through what's the difference between load center, panel board, switch gear, switchboard. That's coming later on. So, but for the time being, now, Joe, what are we specifying for this project since it's dwelling? The cheapest way of doing this project. Panel board or load centers? Load centers. because so all your panels that you're going to have, the 5 panels for the apartments, 1 for the common, they're going to be load centers when you do the takeoff. Single phase load center 24120 done, 100 amp. Typically, that's what you're going to see the calculation. Now the meter, the meter box is going to be, of course, that's a meter center. They make a meter center for dwelling. Again, cheaper product. So that's basically, and I'm going to refer this one, guys, to later on. We'll do the calculation on that. I will do some calculation, exactly what this calculation, guys, in less than a second here. So, and I'm going to go back, calculations. Microwave ovens, the same thing. The only thing I'm going to take that relate to you guys, microwave ovens. If you have a fixed in place microwave oven, typically a very good design is to throw, it's a plugged in, right? You guys, Samir, like you did. So you bring a 20 amp circuit to a plug, and then you plug in your microwave oven. 20 amp, number 12. For dwelling. You're talking about 20 amp, number 12, basically for dwelling. 20 amp, number 12. That's what you're going to be doing. If it's portable ones, they allow you to be plugged in. You can plug it in, no problem. If it's portable one sitting on your countertop, you can plug it in. Do I have to bring a 20 amp circuit for it? If it's portable ones, no. If it's fixed in place, almost always you bring a 20 amp circuit to it. Dedicated 20 amp circuit to it. So for our project, guys, we didn't specify. I know some of you guys assigned a receptacle with a dedicated circuit for microwave. I didn't ask you to do that, so your microwave that we have in the project could be portable, where it could be plugged in, the 2 small appliances circuit done, or I know some of you guys, when you design it, you dedicated a circuit with a 20 amp plug for it, and that's good for me too. Either way. Light wave, I'm not familiar with this, guys. The light wave oven looks like microwave, except look how fast that was. 4 to 8 times faster than the conventional ovens. And that's all we're going to do. When we size these, exactly like a microwave. PTUs, talk about the British thermal units. This is just in terms of heat. When we measure the heat, guys, we measure with this PTUs. Remember the calculator that I gave you? I gave you a calculator that can display PTUs and change them to any other units. Not related directly to what we do. This is just a calculation. Temperature control, guys, read this on your own. This talks about infinite position control that they use with a controller, fixed control, where you can dial and go from one temperature to another on them. So there's a lot of technologies. Typically, Jeff, as you know, we don't really get big designers. We get involved in, these are standalone equipment, guys, manufactured. Our enrollment in these equipments bring with a branch circuit over computation device, pull the branch circuit to a receptacle, and that's where we stop. But it's good to know some of these. 3 coils, automatic sensor control. These are different controls that they use. Energize. So that's all I want to have, guys, about this particular one, at least the ones that's directly related to us. Any comments, any questions before I go directly into my NDC code book and just do a few calculations here for you? Any comments, guys? Any questions? Is it Friday today? All right, so let's go to the NDC code book and do me a favor. Let's go to table 220.55. We're going to be in this table, guys, a lot as we move on this year. But I'm picking one little thing for load. Here you go, this table. So if you can go to this table. Okay. I know you guys have seen this table before, so this is not new. I'm going to review it. If you haven't seen it, please write the following on this table. The most important thing is you have to understand it. When do you apply this table? So we're going to take a few examples. When do you apply this table? The most important thing. First, if I were you, I will highlight it. Number 2, it's demand, so you're going to cut it. Demand factors and loads for household. Can you highlight the words household? So if you guys are doing McDonald's, Arby's, do you apply this table? Out the window. Nameplate. Okay, so that's for, okay, so household. And if you're doing gas, do you apply this table? What are you going to apply it to? Gas. It's electric. You apply it to range, number 1. Wall-mounted oven, number 2. Counter-mounted cooking units, right here, number 3. Can you guys, can everybody write down that these are the 3 places that you apply to? By the way, the ones who are German want to get into a master, pay attention to this one. They throw always a cooking. So number 1, only electric that we apply to, household, so dwelling, and institutional too. They apply to institutional, you see, and for range, ovens, as well as cooking units. Can I have thumbs up, Chad? We got that one? Awesome, great. Okay, so that's the most important thing to understand. First, where it applies to. Other household cooking appliances, and also they lead you to other household cooking appliances. And look at the where. Can you guys see the size that they apply to? More than 1 3/4. More than 1 3/4, right? More than 1 3/4. So what happens if it's less than 1 3/4? Nameplate ready. Thank you. What happens if it's less? Nameplate ready. Don't apply it. Okay. So that's basically the whole thing. More than column C to be used. And I want you guys, the most important thing they used to confuse the people. C is the rule. Everything is the exception. Can you guys write yourself a note? When you use this table, C is the rule. Everything else is what? The exception. C is the rule. Okay? Everything else is the exception. Let's go take an example, will you? Take an example and see what we can do. Can I take an example number 1? And here's example number 1. Let's make it easy. Right in here, I have an overcome detection device, and I'm not showing the disconnect for it, and I'm showing an range, and my range. Let's just say my range. Let's say I have 5 kW. I have a 5 kW range. A 5 kW range. Right, and applying to, and then by the way, this is applied to feeders. To feeders, did we mention that one? To multi-cooking unit. So demand factor and load for household. These are applying. This table applies to feeders. Feeders and services. Feeders, not branch circuit. Can you guys put yourself a note here that applies to feeders? So I have a panel, and from this panel I'm pulling two sizes, one 5 kW and one 4 kW, and these are coming from the same panel, and I have an overcome detection device for this panel. Okay, so I want somebody to tell me I have a panel, and the panel is feeding 2 appliances, among other things. Now, where does this table apply to? And both these are let's say ovens, oven, and another oven, and another oven. Okay, so these 2 are 2 ovens and fed from a circuit. Where does this table apply to? To the branch circuits or the feeders? Feeders. Where are the feeders here? This applies to the feeders. Can you guys see that? This applies to the feeders, not the branch circuit, because the diversity factor goes in the feeders. Okay, so let's go look at these. So we have 2 ovens, 4 kW, 5 kW each. So I have, so are both of them not over 12? Are both of them not over 12? Look at them. Are they both not over 12? Can I have thumbs up, Chad? None of them is over 12. How many of them do I have? 2. What's the demand? The rule. 11. That's the rule. Can I have thumbs up, Chad? Don't look at me strange here. That's the rule. The rule. The exception now. The rule is 2 of them. Are they less than 12? Yep. Is the demand for them is 11. I'm not done yet. I'm not done yet. Everybody got the rule? 2 of them. All of them are less than 12. That's a demand. Now, there's an exception that says if they are within A or B, then you can apply also A or B and choose the one that gives you a smaller size. Do you see where the rule is and where the exception is? Okay, so are they under A or B? Both of them are under B, right? Based on their size, 4 kW. This is 3.5 to 8. They're under B. Okay, cool. Under B. Then the rule, look what the rule gave me. The rule gave me 11. I can go back. If they fit under A and B, I can go to A and B and apply them and choose the answer, the smallest answer, either 11 or less, basically. That's my choice. I have 11 so far. Let's go to the second calculation. I have 2 of them. Are they under B? Yep, they're under B. So what's the weighting factor? 80%. So what do? I take the 5 plus the 4 and multiply it by multiply this by 0.65 because this is percentage. Can somebody do 5 plus 4 is what? 9 times 0.65. What's the demand? 5.85. Thank you. Second, 5.85 kW. Now, which one am I going to use? This one or this one? The smallest. Can I have thumbs up? We got it, Chad. You can see how the rule, this table applies. First, C applies all the time. The rule is C. Then A and B are the exception. If it fits under them. Does that make sense? That's really that. So always start with where do they fit, and we're sizing not the branch circuit. We're not sizing the branch circuit. We're sizing the feeder. The branch circuit always based on the named plate. If I'm going to size the branch circuit right here, or this one, how am I going to size the branch circuit? These two branch circuits based on a 4 kW. How am I going to size the feeder? The feeder is going to be based on 5.85 kW. Can I have thumbs up, Chad? We got that one? Okay, so that's basically what this calculation is. So let me take a snapshot and then erase this one and take another example. So everybody got that one? See that rule? And I'm taking snapshot, meaning you guys will have a PDF file of this. All right, let's take. I like to do the calculation right on that one here, guys, because it tells you, it gives you the big picture. Okay, so this is my calculation. Okay, any question, guys, about that before I take another example? Any question about this? Let's take another example. The other example that I have, guys, I have a feeder, always a feeder, and feeding multiple things right here. Always a feeder. Here's my panel. With Chad, guys, as you move forward, I always like to draw the one-line diagram. Always. Because that's where you know where you are in the system, right? So I have all my equipments are tied in here. Okay, so these equipments, their ranges or cooking, I care less. Their range, cooktop, ovens, all of them. I don't care what they are. But here's what I'm going to take. I'm going to take all of them. I have, I'm just going to take 9, 10, and 12. 9, 10, and 12. 3 of them. 9, 10, and 12. Cool? Now, I want you guys to tell me which one am I sizing. Am I sizing the branch circuits or the feeders? I'm sizing what? Feeder. I'm sizing the feeder. Okay, and we're asked to size the feeder for this panel that feeds all these systems, the feeders. I know there's one for branch circuit. You hold your horses, Jeff, on that one. Okay. Now, what's the default first? What is the default? The default is C. Okay, what's my default? 3 of them at C. Here's my 3 at C. Go all the way to this one. What's my default? 14. Okay, that's a default. Now let's go. Do I have any other exceptions? Are any one of them under A or B? No, so we're done. You guys see where you go do the default first, then you go ask yourself, are any one of them under A or B? No, done. Cool? So what's my default? It's 14. Well, let's go size the system, will ya? It doesn't, up to this point, that's math for knowledge. Let's go size the system. So I want to go size the feeder. So number 1, feeder conductors. Feeder conductors. Okay, how do you size a feeder? Now I have 14 divided. What's the voltage system? This is only for single phase, so 240. So divide by 240. I need a gentleman to do the math for me, and another gentleman to second him. So 14K divided by 240 is what? 58.3 amps. Cool. Now this is non-continuous load. Done. Okay, so you're going to take this number to where? Table 310.15 B16. And if it's a feeder, and can you find me guys a conductor? Is it number 6 wouldn't get you there? Number 4? Can number 6 get us there? I can't remember. Number 6 got 60, I think 60 amps. 310.15 B16 under 60-degree column. 60-degree column. What would that give? Number 6? Okay. So I need how many conductors? Number 4, number 6. Number 4 or number 6? Adam, number 4 and number 6, guys. 310.15 B16. Anybody? What, Jeff? Did you guys get it? 4? So 58.3. 310.15 B16, no derating. Number 4?
Number 6 is 55, so I mean,
So
50 degrees?
no, 60-degree column.
Yeah, 55.
So that will give me number, so that will be
Sorry,
number,
my bad, it's number 4.
number 4/4. 4.
I'm a little slow on the line.
Okay, 4/4. So you need a cable of 4/4, right? 4/4. If you're pulling a cable, if you're pulling a conduit, it's going to be 4 conductors. Now the neutral, we derate the neutral. Mind it that we can derate the neutral. But so that's the size of your feeder. Number 2, overcurrent protection device. What's the size of the overcurrent protection device? You take the 58.3 amps, take it to 240.6. What's the next standard overcurrent protection device? That's easy. 60 amps. Can 60 amp protect a number 4? Does number 4 have 60 amps or more under 60? That's what I'm asking. Does it? Can you guys check it? That's a check that you need to do. So my overcurrent protection device is 60, and my conductor is number 4. Does that match based on 60? Does it? Okay, we're done. So we size the feeder that's coming to this panel. Can I have thumbs up, Chad? That's why we do this calculation. That's why we do this calculation. Any question, guys? Any question? That's why we do this calculation. Because at the end of the day, Jamie, my friend, you're supposed to come up with the size of the feeder. At the end of the day, you're supposed to come up with it, right? Otherwise, it's just math for the sake of math. Another example. You guys mind me doing the examples right on the table here? So let's go take a snapshot on that boy. Okay. So let's go take one more example. Any question about this before I leave this? Any question about it? Anybody has any question about it, guys? Let me see if we have them. Okay. We didn't get the first one. All right. Okay. So let me go erase this and have another example. Another example on the same calculation here. I'm going to leave my feeder the same thing because eventually we're sizing feeders, right? Sizing feeders. Okay, now let's go size one more example. Take another example. I have 24, 9, and 24, 9, and 20. And each one of these, I have 3 of this, 2 of this, 5 of this. Cool? Are you guys with me? I have a panel that feeds an apartment building, and they have ranges. I have 3 24, and 2 9, and 5 20. Any issue with that? Same thing. I want to size the feeder. Any issue with that, guys? Everybody's okay with this? Okay. Now, we need to size the feeder and the overcurrent protection device, which is this one. So I need to size. This is number 2, and this will be number 1 for sizing. That's why I care. I need to size the two. Number one and number this one and this one. Okay. Now, how many ranges do I have altogether? 10 of them. Okay. Now, are they under C? Okay, C is the default. Are they more than 12? Okay. Now, if you guys, I can't scan it here. Well, I can. If you go down here and to note number 2, if it says if it's over, can you guys see this note number 2 here? It says if it's over this note. If you read it, it'll tell you if it's over 12, okay, if it's over 8 and 3/4 and less than 27, you add them up, you average them, you increase the average 5% for anything more than 12. Can you guys, if you read this, it will tell you, are they all more than 8 and 3/4, right? Are they different sizes? Yep. So here's what this note will tell you. Here's what you're going to do. Add them up. Anything less than 12, make it 12. Average them. Increase the average by what? 5% for every KW more than 12. Let's go do that. So I just thought to show you this one if you think I brought it from my basement here. Let's go and do this. Okay, so let's do that. Let's do which color? Let's do green now. So I'm going to do, okay, so I have how many? I have 3 times 24, right? 24 plus the 9, all the 9s have to go to where? Up to 12. Anything less than 12, that particular note, Andrew, anything less than 12, you have to move it to 12 based on note number 2. This is less than 12, so that would be 2 times 12 plus 20. 20, no problem. 5 times 20, okay? And divide them by their number. How many of them do I have? I have 3 plus 2, 5, 5, 10. Divide by 10. You guys remember how we find the average? That's how we find the average, right? The average. Everybody can give me a thumbs up, Chad. This is how we find the average. So that's step number 1. You're going to find KW average. Okay, I need 2 gentlemen, or a gentleman and a lady. We don't have ladies, so it has to be 2 gentlemen. 2 gentlemen who can agree on one answer. One answer? 92.6. Second?
19.6.
You did the calculation already? What are you using? Your computer?
Yeah.
My God, you're faster than. Okay, 19.6. 19.6 kW. Okay? 19 exactly 0.6. Everybody's okay with 0.6? Because that 0.6 will make a big difference. 19.6. Can I have thumbs up, Chad? Piece of cake. We know how to do the average at least, based on number 2. Piece of cake. Let's go to the next step. So that's the average. Now, for how many ranges? 10 ranges under C. What's for 10 ranges under C? Let's go 10. And under C, what do you get? 25. 25 kW. Okay? For the 10 of them, under 25, it give you 25, right? Under C, give you 25. Can I have thumbs up, Chad? I get the 10 because it's 10 ranges, give you 25, okay? Now, note number 2 says, increase the 25, 5% for every KW more than 12, okay? So let's do it. Step number 1, we found the average. Step number 2, we found the KW based on C for 10 of them. Then, step number 3 here, you're going to find 19.6 minus 12. Where did the 12 come from? From the note number 2. So what's 19 minus 12? That will give you what? 7.6. 7.6. Anything higher than 0.5 becomes what? Up. You go up. If it's 0.5 or higher, you go up. So that becomes 8. So we are 8 kW more than 12. Can I have thumbs up? We know what 8 kW more than 12 is. Okay. 8 kW more than 12. So, final answer. Let's use red here. The final answer. I'm going to increase. So I'm going to take 0.05, 5%. This is how I do the whole complete answer myself. I would go 1.05. Okay. before I go, everybody knows what the 1 stands for. 1 just to get you the 25 kW. The 0.5 to get you the increase. Okay? Multiply this one. Oh no, that wouldn't get you there. It would be different. Okay, so I have the 0.05. Multiply this by 8. What would that give you?
40%.
40%, 0.4. So I have to have 40% increase, right? The last step is to take 1.4 and multiply it by what? 25, and what would that be? 35. 35 kW. 35 kW. So what's the demand for all this junk here? 35W. If you add them up, what was all of them together? They're much more than 35W. Why do we do this add up? Because it's highly unlikely like this is typically for apartments. You're not going to have all these in one house. Apartments, highly unlikely that everybody in the apartment, other than Thanksgiving maybe, is going to be cooking, fully engaged at the same time. They call it diversity factor. Any question guys about this? Now up to this point, nobody gave you money yet for doing this. This is mental exercise. Let's go size the feeder, 1 and 2. We need to size the feeder, guys. We need to size the feeder. Otherwise, it's mental exercise. Okay? You guys understand it's mental exercise up to this point? Okay. Before I take a snapshot at this boy, okay? And again, I'm doing a snapshot here. Any question guys about this? Oops. Any question about this? Repeat. I have 10 ranges, different sizes. All of them are higher than 8 3/4, so they're all under C basically. And then the demand for them, very clear, 25. But I have to increase the demand 5% for every kW. The average is more than 12. So the first thing I did, I averaged them. And the most important thing is I did here is anything less than a 12, I made it 12. Averaged them, I found the average. Now for 10 of them, 25. Then you take the average minus 12 because note number 2 says so. We give you 7.6. Anything higher than 0.5 becomes 1. That will become 8 kW more than 12. This is 8 more than 12. You increase 5% for every kW more than 12. That'll get you an increase of 0.4. Then you up your number that you came up with, 25. You up it 40%. And that's how you get your answer. Can you have thumbs up, Chad? We know how to do that? Okay, let's go size. We're not done. We're going to go size the system now. Now let's go. This is mental exercise. Can you guys remember what was the 35? Yeah, you're going to give me that number because my memory, I have short memory here. Okay, so now that you guys have done that, piece of cake. Now let's go size number 1. Number 1, what did he say? Feeder. Feeder. Okay, for feeder, give me the amps. What the kW? 35. Even? Yeah. 35. So I have a 35 kW. Divide this by 240. I need 2 gentlemen to give me a number. 145.83 amps. Cool. All right. So now, we're going to take the 145.83. Take this one to 310.15 B16 under 75-degree column. Why did I go under 75-degree column now? Anybody can tell me why did I go 75? Thank you. More than 100 amps. I moved to 75. The minute that you hit the 100 amps, more than 100 amps, what do? Switch to 75. Okay, how many conductors? How many conductors? I need 4 conductors. This is where I want to introduce a new little thing here. I need 3 conductors. I'll tell you why I need 3. Well, let's say the system, my voltage system is 240/120 volt. Okay, that's my system. So let's size the phases first. 310.15 B60, what's the size? Under 75. Under 75, guys, come on. 1 aught, I need a second. Second, 1 aught. So I have 2 conductors, number 1 R. A, W, G, T, H, H, N. That's what engineers do. You have to specify the wires. What happened to the neutral? They allow you to derate the neutral for ranges. That's why I'm going to get into derating the neutral for ranges. The neutral for range, guys, they allow you to derate it 70%. Based on 250, 220.69, I believe, or one of these, neutral. Yeah, 220.61. Permitted reduction for the feeders and the neutral, 70% on the following ranges. So I have two huts. I need to do the neutral to make it spice it up a little bit for you. Okay, so these are this one for hot 1 and hot 2 for the two huts. Cool. Let's do the neutral. You guys have an issue with the neutral? Let's do neutral. For neutral, in neutral you take the, where's the number here? 145.83, multiply it by 0.7. Where did Chad got up with the 0.7 here? Where did I get 0.7 here? This is coming from 220.61. 220.61 B. Thank you. B as in boy. Okay, because the neutral, why do they think they derate the neutral? It's highly unlikely the neutral is going to be loaded in all these ranges. So, can somebody give me the answer for this, please? What's 0.7 of that one?
102.
102? 102 amps, right? Everybody's okay with that second? All right, so let's go size that boy. So take this one to the same table. 310.15 B16 under 75-degree column. We're still more than 100. What would that give me the size? 1 under 75. 2. 1 conductor, number 2. So when you pull inside the conduit, what do you need to do? Based on only these loads. Now, if there's other loads, you still have to add. Based on these loads, what do you need to pull in these conductors? 3 conductors you need to pull. One of them is, 2 of them are 2 hot, and 1 is number 2 for neutral. Can I have thumbs up, Chad? We got that? That's where we become, that's why we do all this stuff, right? Now let's do the calculation. The last thing is number 2, over current protection device. That's piece of cake. The over current protection device, you take it based on this number, 145.8 amps. You're going to take 145.8 amps. You're going to take it to table 220.6. What do you get? What's the next standard? 150? If you guys go to 220.6, is the next standard 150?
240, that's it.
240.6 is it? So there's 150. 145.8 go up to 150, right? Darren, do you guys 150?
Yeah.
Okay, 150. Now I want Darren, do me a favor. Can 1 knot carry 150? That you have to check that one. Can 1 knot carry 150 under 75 or more? 1 knot under 75 copper, can it carry 150 or more? Does it? Okay, then we're good. If it doesn't, then you have to go down on the overcomputation device. Can I have thumbs up, Chad? You have to check at the end of the day, your conductor 1 knot have to be able to carry that. They actually allow you, at this sizes, they allow you to go a little bit higher again. Okay, any question guys about this? Can I have thumbs up, Chad? We know how to size these. We know what this is all about. Okay, so that's basically what you're gonna see. Any comments, any question? Brian, my friend, are you there? Okay. Any questions? Any questions? Tough night. Any question, guys, about this? Can I have thumbs up? Okay. I'm going to give you a 5 minutes break, and I'm going to take two more examples, and I'll promise you to shut up after that. Two more examples, okay? Let's have 5 minutes. So let us go. So everybody knows what we have. We have a panel that feeds 3 loads through 3 branch circuits. One load is 13 kW oven through a branch circuit. One load is 2 cooking units and 1 oven through a J box, which is allowed. And the third load is a standalone cooking units, 6 kW. Can I have thumbs up? We understand what's in this panel. If there's other things in this panel, we can add to it. So here's how we're going to handle it. First, we need to size the feeder, and then we go size the branch circuits. Okay, we're going to size the feeders. So for sizing the feeders, guys, here's what I'm going to do. I have, so let's, first of all, how many equipments do I have? How many equipments altogether do I have? Right? I have 1, 2, 3, 4, and 5 of them. So for 5 of them, my derating factor is 20, right? 20 for 5 of them. But there's one little problem though. One of them is 13. One of them is 13. So that's gonna. So in a case like this, here's what you're gonna do. You're gonna apply each column to each things that apply to it. So let's start with column A. Let's do under column A. So I'm gonna go under A. What's under A? Under column A, right here. How many do I have under column A? Basically, do I have anything under column A? 1, 3. So for one of them, what's the derating factor? So you're going to take the 3, multiply it by what? 0.8. Okay, that's under column A. So what do you get?
2.4.
Thank you. 2.4 kW. Done. Under column B, let's go to column B. Everybody knows. So under A, we done. Under column B, what do we have under column B? We have 3, 4, 5, and 6. So here's the 3 of them. Under column B, the derating factor is 5. Under column A, we found, so under column B, 3 of them, derating factor of 5. So what do? I add them up, so I have a 5 plus a 4 plus what? A 6. Add them up and multiply them by what? 0.55. And who is my genius? Who's going to give me the answer here?
8.25.
How much?
8.25.
8?
8.25.
8.25 kW. Cool. All right. Okay, so that's what we do. Okay, the last one is column C. So let's do column C. Let me erase these and go directly into column C. Column C, under column C, how many of them do I have in the column C? 1. Now, that one, is it 12 or less? No, it's 13. So how do you do that? First of all, the derating factor for one of them is what? 8. So I have 8. Right? I have, let me use a different color here. I have 8 plus, how far is 13 from 12? 1. So you have to increase this 8 by what? By 5%. So I'm going to write immediately 1.05 times 8. Can everybody understand why did the 1.1? Because it's one of them, 8. The 5% because it's 13. It's more than 12. Can I have thumbs up? Everybody got that one? Okay, give me the answer.
8.4.
8.4 kW. Okay? All right, so here's all my derating. Now, the last one is total. What do you do with the total then? 2.4, can somebody do that for me? 8.25 plus 8.4. Can anybody give me the answer, please? 2 gentlemen agree on the same answer?
19.05.
19.1 kW. Give or take, like 19.05, 19.1. Can I have thumbs up, Chad? Got it? Okay. So that's for the feeder. That's for the feeder. That's how we size the feeder. Everything they've done here is for the feeder. Okay, for the feeder. Now let's go size that boy. So now sizing the feeder. Feeder. For the feeder, I want to do 2 things, guys. Number one, I need to do the conductors. Conductors, let's do that. So take the 19.1 divided by 240. What do you get? Don't forget the K. 19.1 divided by 240. 79.58, 79.6. 79.9. Okay? Is that good? 79.9, right?
79.6.
79.6. Thank you. 79.6. 0.6 amps. Okay. Everybody's okay with this? Cool. Now, let's go size the conductors, the hot conductors. So I need hot 1 and hot 2. Hot 1 and hot 2. You go to 2, oops, not 240. Where do we go? 310.15 B16. Okay, what do you get there? Under 60. Why we're going to go to 60-degree column? Because it's an 100. What do you get? Two conductors, number? Number 2 conductors, number 3. A, W, G, T, H, H, N. All right, let's do the neutral as long as we're on it. The neutral. What do we do in the neutral? Thank you. Where's my number? 79.6. Multiply this one by what? 0.7. What do you get?
Number 4.
How much?
Number 4.
No, the M.
The total 55.7.
55.7. And if you take it to 310.15 B16, what do you get?
Number 4.
Number 4. So we went one down. One conductor, number 4. Okay, so here's my conductors. Same thing, THHN. And here's my, so I sized my feeder conductor. Can I have thumbs up, Chad? We know how to size a feeder conductor. So that will be number 1 right here. Number 1 right here. Cool? Before I leave here, gosh, I'm gonna size the overcompression device and then I'll go over it. So I'm gonna go put it right here. Number 2. Number 2 is the overcompression device right here. This is number 2. Okay, this is easy, guys. Overcurrent protection device. What was the amps for the whole feeder? 79.6. So where do you go? 240.6, and what do you get? 80 amps. So how much is my overcurrent protection device? Is it too hard to follow up with that? Sorry. So overcurrent protection device, you take the 79.6 amps, take it to 240.6. Everybody knows what 240.6, right? 240.6. And from there, the next standard is what? 80 amps. Are we good? Got 80 amps. Huh? What?
I looked down for a second. I lost you.
Oh, I was. Am I here?
I got
Are you okay with that? Okay, sorry. Everybody knows what we did. We did the demand, and we sized the overcompression device, and we sized the conductors. That's what we do, right? All right, so let's take a snapshot and go do the rest. So take a snapshot. All right. Would you guys be able to do that? Everybody, would you be able to size that feeder like we did? Cool. Can I erase when you guys are ready? Now the next scary, my friend, I sized the feeder, overcompression device, the circuit breaker, and the conductors, hot and a neutral. Next, I'm going to size the branch circuits right here. I'm going to get into sizing the branch circuits. I'm going to show you how sizing the branch circuits is different. Sizing the branch circuits is different. Let me know when you guys are ready. While I go get myself a cup of coffee here.
I love drinking white stuff. Sometimes.
Is he okay?
I'll be done.
Just for the record, guys, we're recording on here. Do I have to erase?
Way to go, Brian.
Do I have to erase? Oops.
That's gonna be on YouTube.
Do I have to review that just for the record? I'm if I leave the room.
Well, for the recording,
All right.
just for the record, Brian likes drinking light stuff.
Okay.
I doubt there isn't anymore.
You can tell it's Friday, huh? All right, let's go do the branch circuits,
Really bad.
and then we get it.
Okay.
Yeah, what if you double tap it, does it erase it all? Do you erase it out?
Double tab.
Yeah, shoot it once in the head. Oh,
Okay, here's the deal. Just hold the eraser in your one hand,
Uh-huh.
circle the board, like take it off the board,
Oh, it didn't do anything.
take the eraser off the board, and then just like circle it with your finger or whatever.
I can erase, yeah.
Make like a circle, and you just tap in the middle, and the eraser's off.
Does it?
Yeah, and then they do a circle around it, and then tap it in the middle.
really?
You're the genius.
Go
We'll
up
try
and
it
tell
after.
them.
We'll
Yeah,
try
let's
it
do
after.
this.
We'll try it. Thank you. We'll try it after.
There you go.
Okay. Guys, everybody knows what we did. We sized 1 and 2. Now here's what I'm going to size. I'm going to size this one. I'm going to call this one number 3 and number 4. And I'm going to call this one number 5 and number 6. I'm going to call this one, the conductor here, number 7 and number 8. Are you guys with me? Just conductor over computation device. Conductor over computation device. Cool? Very easy. You're going to see it's really easy. Easy for you, Chad. Really easy. Okay. Now, this is an oven. There's an exception in it. And is this a branch circuit or a feeder first? Branch circuit. Does this table apply to it? No. No. The answer is no, except if you roll down a little bit here, that's where they catch you. Just a little bit, and you go down to and read right here. If you read this, it will tell you for a branch circuit, you can apply this one for a 1 oven branch circuit, and 2 countertop and 1. You can apply the same table. You can apply it for 1 oven as a branch circuit. And you can also apply it for 2 cooking units and 1 oven. If you guys read number 4, it tells you. If you have 1 oven, no problem. As a branch circuit size, a branch circuit for 1 oven based on this. And if you have 2 cooking units and an oven fit from 1 branch circuit, do I have 2 cooking units here and an oven fit from 1 branch circuit? Then also apply the same rule to it. Can I have thumbs up? We understand, Chad, what's going on here? All right, let's go up a little bit. Then can we apply this rule for the first one for number 4 then? Number 13, yes. So let's go do it. So for 13, I have 1 conductor. So what was the demand for 13? We did that. So I have 1 of them, 8, and I need to increase it. So I'm going to say column C for the 13 kW. That will give me 8 times 1.05. We did this one. What was it? 8.4. Thank you. kW. Everybody, you guys got that one? 8.4. We did that one. So can I do it for a branch? Now we're doing branch circuit. Yes, you can because of that note. Okay, good, Chad. We got that one. So now piece of cake. Take the 8.4 kW divided by 240. I need 2 gentlemen to agree on one answer. 35 amps. Cool. All right. So let's take a 35 amp. I have 35 amp. Take it to 310.15 B16. What's the answer? What's the conductor? Number 6 or number 8? Number 8. So how many conductors? 2 conductors. Number 8. 2 conductors, number 8. Okay? 2 conductors, number 8. So that will be number, in this case, number 3. So we did number 3. We sized the conductor for number 3. Okay? Can I have thumbs up, guys? Okay. Now, for this particular one, guys, there's an exception in the code that says if you have a range, the branch circuit cannot be smaller than number. If you have one range, and the range is more than 8 3/4, remember we went the branch circuit cannot be smaller than 40. So whatever you can come up with here, it has to be more than 40. Okay, so let's go size So number 4, the overcurrent protection device. Same thing, 35, take this one to 240.6. Is there a 35 circuit breaker? 240.6? Can you guys check? 240.6. There's 30 for sure. Is there a 35 or do I have to go to 40?
Yes.
Yes, there's pretty much.
Okay, so 35. But here's one little problem. Remember that little rule? The little rule that says, guys, if it's 8 3/4, I can't go less than 40 anyway. So I'm going to jump to where? To 40. Just because. So this has to be what? 40 amps. And then you ask yourself, can 40 amp protect number 8? Yep, I'm good. Everybody knows why I jumped to 30 from 35 to 40, because there's a rule that says if your range as a branch circuit is more than 3/8, then the branch circuit cannot be less than 40, period. So we have to do 40 anyway.
You know what code section that is?
220. Oh, if you go to 220.55, yeah, 220.55. I think 220. I think it's 220.55. No, it should be in 210 though. No, it should be in the branch circuit. Let me just finish. I'll find it. I think it's where's 210? Go to 210 in the branch circuit. It should be there. Okay. Any question, guys, about this? So we sized the branch circuit for the first oven. Can I have thumbs up, Chad? We got the first oven. All right. Let's. I'm going to go just because of the ease of installation. I'm going to go, guys, do 8 and 7 and 8 and skip the rest of them for a second here. So let's. So we're done here with this guy. I'm going to go to 7. For item number 7, I'm skipping 6, 5 and 6 because I need to have more space for these. I went to 7. 7 is 6 kW cooking unit. Is it an oven? It's a cooking unit. Can I apply this table to a cooking unit as a branch circuit? It doesn't seem so because it under the table says the branch circuit load, branch circuit. It shall be permissible to calculate the branch circuit for one range in according. Is it a range? No. It's a cooking unit, one of them. Can I apply this table to it as a branch circuit? No. So what are you going to do? Use the nameplate. So we're going to use the nameplate. Okay. So the table really doesn't mean anything here. So I'm going to take the 6 kW divided by 240. How much?
25.
Wow, even 25 amp. Everybody knows why I put the full 6 kW here? Because it's not an oven and I can't apply to the table. I can't go cut it by, typically I would cut it by 0.8. I can't do that because it's a branch circuit. It's not, and it's a branch circuit for a cooking unit, not an oven. Can I have thumbs up? We got that one from note number, what was that note? Number 4, I believe. All right, so piece of cake. Let's go size then from here, my friends, it's really piece of cake. You can go here, 310.15 B16. What's the size? Number 10? 2 conductors, number 10. By the way, instead of 2, just put 3 conductors because I don't want to derate the neutral. If you want to derate the neutral, the same thing. You take, we don't derate the neutral for the branch circuit, so that would be 3 conductors. 3 conductors for all of them instead of 2. 2 hots and a neutral. 2 hots and a neutral. For branch circuit, can you guys change this one to 3 conductors? It's a branch circuit. We don't derate the neutral, so we get it 3 conductors. 2 hots and a neutral. I just changed this one here to 3 if you guys, 3 conductors. Okay? So 3 conductors, number 10. Done. Let's go to the overcurrent protection device. Number 8. Number 8, overcurrent protection device, aka the fuse or circuit breaker. It's 25 amp. Does the 25 go to what? 240.6. What's the next standard 25? Well, is it a standard first? Yes, so I stick there. 25 amp. Okay, so do I have to go to 40? No, why? Because this is not an oven. It's a cooking unit. It's a cooking unit, it's not an oven. So you have a 25 overcurrent protection device protecting number 10. Is that okay? Yeah. 10 can go all the way up to 30. Okay? Typically, guys, in an application like this, because number 25 is not commonly used, what people do is they put 30 amps on number 10 and call it a day.
That's what I was gonna say.
Yeah.
You're not gonna special order a breaker. So
That's
you're gonna
exactly
go
so.
for the industry.
So typically, and can we do that? Yes. Because you're sizing to protect the conductors, basically. Because conductor number 10 can go. But strictly speaking, based on calculation, I need 25. Any question, guys? Can I have thumbs up that, Chad? We know. And I need everybody to understand 7 and 8 were sized based on the nameplate, based directly on the nameplate. There's no exception in the code to upload. They're branch circuits. Cool? I'm going to take a snapshot, guys, on it and do the last thing, which is okay, now where's my friend who said now you can delete it all at once? Come over here. How do you do it?
That's the next year.
I want.
That's not gonna work.
I don't want to delete this. I just want to delete this stuff here. Everybody got it though before I delete it? I have it as a PDF too. Okay.
It's gonna erase the whole computer.
Don't, okay.
Oh, Cuba.
Genius.
I
I don't know about genius, but
Chad, I have the instruction manual open and it says how to clear the whole page.
Oh my God. So you went all the way here. Can I hire you as an assistant here? And here I am. Now you made my life easier, man. Thanks. Manuals? What manual? Do we read manuals? We're men, man. Don't read manuals. Are you kidding me?
Cuba.
Damn kids with their technology.
We spend twice as long just figuring things because we don't want to read manuals. Thank you. That's cool. That's a good one. Just you have to close the circle there. I wasn't closing that circle. So that's cool. Okay, the last thing I'm going to do, guys, is 5 and 6, which is piece of cake. 5 and 6, and so let's go to number 6. Number 5. Okay. Now there's the code says the following. The code says you can treat 2 cooking units and 1 oven as a range. 2 cooking units and 1 oven as a range. Only no more than 2 cooking units. That's note number 4. Do we have more than 2 cooking units on the same branch circuits here? No, there's 2 cooking units and 1 oven. I can add them up and treat them as a range. So let's do that. Add them up, 5, 4, and 3. So add 5 plus 4 plus 3. Can you guys give me what 5 plus 4 plus 3 equal 9, 12? 12 kW. Okay? Everybody's okay with that? 12 kW. Now we add them up. Now we're going to treat them as an oven. Since they're an oven, can I apply the table to an oven here? Yes, for 1 oven. Okay, so let's apply the table. 1 oven, 12. What's the 1 oven 12? 8. Done. So the demand for this boy is what? Is 8 kW. Can I have thumbs up, Chad? We know exactly what you have done. And I put your record. I should take a picture of that one. What do you say, thumbs up? So everybody understand, because there are 2 cooking units in an oven, add them up, treat them as a range, apply the table to them. You take 1 range under C because it's 12, it just gives you number 8. Do I need to cut the number 8? No. Everybody's okay with this? Cool. Now the rest is history. Let's take the 8K, kW divided by 240 equal what? 33.33 amps. Then take this 33.33 amps, take it to 240, not 240. In this case, take it to 310.15 B16. B16, oops, that's even I can't read it. 310.15 B16. What would that give you? Number 8 or number 10? Number 8. 3 conductors, number 8. Okay? As long as we're on it, let's find 6 too. So 33.33, take it to 240.6, that will give you 35 amp. That will get you 35 amp. Okay? Now, do I have to go to 40? Well, the code says you go to 40 if it's 3 3/4 or more. Is the range demand for me 3 3/4, 8 3/4? Is it 8 3/4? No, my demand was less than 8 3/4. So you stick with 35. So I have a 35 for this feeder, 35 kW, 35 amp.
But once again, you bump it to 40.
But it's not the range.
Well, because of the breakers. Well,
Oh, the breaker is typically we don't carry breaker 35, guys. So you put it in 40 anyway. You end up practically putting it in 40. Then you ask yourself, can the 40 protect number 8? Yep. Okay. All right. The last thing, and I promise this time it is the last thing. Now we have a tab here. Can you guys see that little tab here? Which color am I going to use with this tab? Blue. Can you guys see the tab here? I need this. I'm going to call this is. I have 7, 8. I'm going to call this is 9, and this cable here is 10. I need to find this little tab, right? I have this conductor. I came up with number 5 is actually number 8. I can continue with number 8 and I'm done. I can actually continue with number 8 right here, branch out number 8 and I'm done. But can I go lower than number 8? Yes, because these little tabs are feeding only individual loads. So let's do that. Now there's no overconduction device here. I want to remind you, it's only cable tabbing. So let's do 9. 9. What's the load that you're feeding from 9? 5 kW. Now you have no choice. You're not going to wait to do anything. 5 kW divided by 240. What do you guys get? 5 kW divided by 240. How much? 20.8 amps. Okay, now 20.8 amps. 310.15 B16. What do you get? 3 conductors, number 10. Thank you. 3 conductors, number 10. So I tap with number 10 conductor to this load. Okay, let's go to the second load. Let's do the second load. Number 10. Number 10 is 4. So we take 4 kW, divide by 240. What do you get? 16.6 amps. And what do you take 310.15 B16? What do you get? 3 conductors, number 12. So I took number 8 to a J box, guys, a box, and from there I tabbed into number 10 and number 12. Can I continue with the number 8 all the way through? No problem. Any question, guys, about this?
That tab can only be 10 feet long.
Yeah, there's a rules tab. Typically, for this rule to apply, guys, they have to be in the same room and fit from one branch circuit. So if they're in the same room, fit from one branch circuit, typically with a 10-foot rule. There's a 10-foot rule and a 20 feet rule. 20. What is it? 20 or 25? 25. 20 and 10 and 25. 10 says the overconduction device here cannot be less than 1/10 of what the conductor can carry. I guarantee you we're good here. But we will get into the tab rules. There are tab rules that you have to adhere to. So basically, you're going to take the amp of number 12, the amp of number 10. The smallest is number 10. The amp of number 10 is what? 20 amps. Okay? So the overconduction device cannot be more than 10 times the ampacity of number 12. So 10 times 20 is what? 200. Do you have a 200 circuit breaker here? More than 200? You're good. We'll get into the tab rules when we go to the commercial. Any question, guys? I know you did it with Gary. I don't know if you did it this way with your size. Maybe you did the calculation. Did you guys do the sizing as well for feeders? When you come to the design, we do the calculation. Is just if you do calc, like the rating, this one is just mental exercise. For us, guys, we have to end up always with 2 things for anything that we size. We have to end up with an overconduction device and a feeder. That's our job. Everything you do, if you don't end up with a feeder and overconduction device for the load, call it mental exercise. Might as well go do algebra. You know, does that make sense? Why I draw the stuff here? Because that's now change from a mental exercise into actual. Jeff and Darren, I can give you now this one. You can go wire it, no problem. You know, you have an overcurrent protection device, you have how many conductors, what type of conductors. You know, later on, I didn't put the conduits here. Here you can wire with cable, but later on we're going to size the conduit size that you're going to put there. And when we do the takeoff and estimation, now you can estimate this project because you know what you have. Can I have thumbs up, Chad? We know exactly what you're doing. That's it. Now you're not going to hear Chad talk about this again until I'm going to review for the test one time, and that's about it. So hopefully that's good enough as quick review. If you guys you haven't touched on these, I go deeper in it. But since you touched on it, I think this is good for what we need. Okay. I want to remind you the apartment building, guys, that we have has 4 ranges. Each one of them is 8. So when we do the load calculation the week after next week, you're going to use the same rule for our apartment building. So since it's number 8, every range you're going to size it basically 40 branch circuit. But overall, for the panel, for the main panel, you're going to take 4 number 8. So 4 of them are number 8 under here. So here's 4. Number 8 will give you what's the cut? Right? 0.5? 0.5. So you're going to cut them by half. Cool? Okay. So thank you. That's all I have, guys. Thank you. All right.